Hi everyone, welcome back. Lastly, we checked how to use this, how to initialize this SIFT class. Also, we compared SIFT feature detection with the other feature detection we already learned. And in this video, we are gonna focus to this member functions parameters of this SIFT class. Okay, we can directly switch to the code part. And here, this was the code from the previous video. So basically, we were just initializing the SIFT class, and after that, we are detecting and the computing. And also it's good to see here, which is the key point size, which is the corners or key point you can call the size of them. Also descriptor size, which is corresponding 64-bit information of each key point. We can run it again and see how it looks like with the default parameters. And you see here 76 key points are detected in this picture, and also for each 76 we have 128 information. I mean, we have an array 128 to 76, so each point has an ID with the number of 128 numbers. Okay, and okay, now we can go by one by, and here we can open one more maybe, so we can go to the SIFT class. Here is that, so we can focus by one by. So this is, I was just checking, and here are the member functions, which is number of features, octave layers, and contrast threshold, and goes like that. Okay, we can start with this one in this order. So set n number of features. This n is number, so this is easy to understand. We can just also, I want to see the default one, so we can just call SIFT and get number of features. So let's see the default one. Maybe default one is -1 or something like that. So it's 0, but of course it's 0 is representing limitless. So whatever key points you are finding, just show that. So there's no limitation for now. But if we make after the console output, we can set the number of features, let's say 12. So now I want only to see at the end 12 key points. So in here we were seeing 76 detected key points. Now we are expecting it to be 12. So you see 12. So if you make it 5, you are gonna only see 5 key points. So it's kind of we are limiting that number of features. So why this can help? Maybe after the 5 iteration, after the 5 findings, is not gonna try anymore to find any new feature. So this is gonna help you to be efficient. Okay, and this was the first parameter, and this is done. The next is the number of octave layers. Since we talked about this in the previous videos much, so you can check them. This is similar with the other kind of feature detection types, so I'm skipping that. This contrast threshold also controlling the contrast. For example, since we have a very sharp, very contrast image, so it's not gonna work well in our case, but we can still try. Let's say just default one is 0.04. So let's kind of try to increase. The lower values is gonna be tried to be more contrast images, or no, so increasing is gonna be more sharpness. So if we make it 1, let's say, I'm expecting to see less results. For example 0, we increase really much, so let's make it 0.1. let's see how it looks like. Now we see still same, and maybe 0.6. So now we are, since increasing the contrast, we are expecting it more sharp. So we are expecting to see less key points. Okay, for example 76, now 66. So we decrease. So yeah, it's kind of we increase the image in the behind, the contrast of the image. But if you make it really low, which is like this maybe, now you are gonna see, okay, maybe just put like this. Don't know. Okay, now you see, oops, you see weird number of the detections, which is 3000 detected, because we really decrease the contrast kind of in the behind, so it gives us weird results. Yeah, this contrast, if you are working with the less contrast image, you can play with this parameter and you can check the result at the end. And this threshold is the threshold parameter of this SIFT This is, since in the comparison part also we talked in the previous videos, this is kind of this is taking behind very careful about this edge thing, so it's important. For example, the default one is 10, and now if we increase this, it's gonna give us less results comparing now set edge threshold. Since it was 10, if you make it 100, maybe you will get nothing or kind of less things. Oh, increasing, giving more results. Why it's like that? I was expecting the opposite, so it's working opposite logic also. So then if I make it 1, it's gonna give me less results. So yeah, it's working oppositely. Let's make it 5, because normally if you increase the threshold, you expect to see less results, but yeah, this is working oppositely. And yeah, it's just eliminating, but almost giving the same points, nothing else. So it's just eliminating. For example, this star, before we see something around this corner, but now we don't see. But if you make it 20, I think we are gonna see some new, yeah, we are gonna see why it's not directly matching. Actually, with the parameters even we are playing, it does not directly detect these things. This is maybe about the SIFT algorithm. Yeah, it's not really sharply detecting those points. I also don't know. You can play around, but if you have an idea why it's not directly detecting these points, you can write as a comment. Because I play before I'm starting to this video, I also played around, but it does not directly detect those points accurately. Okay, this get sigma is about in the behind using a Gaussian blur kind of thing. So this sigma from the Gaussian blur we also have a video in my YouTube channel about the Gaussian blur. The sigma representing that somehow, so it's currently 1.6. If you increase this sigma, kind of increasing the blurriness, so you are gonna get less results, I expect. So 1.6, currently we are getting 76, and now we can change sigma as, let's say, 2 maybe, which is kind of we are increasing the blurriness. So yeah, now we get more points. This is also working than opposite logic. But if we increase the sigma, increasing sigma, kind of increasing the blurriness, I'm also lost in here. But yeah, maybe we can make it 1 and see. So now we expect, okay, even you increase, even you decrease, you both, yeah, both is just increasing the key point. So this is not totally related to blurriness, then this is somehow related, and another parameter of this SIFT is using behind. So yeah, if you also have more information related to this sigma, you can write to the comment what happens we put different kind, because there's no clearness, because we increase and decrease, both is increasing the key point number at the end. Okay, yeah, I'm done for this video thing. Also in here, the sigma of Gaussian applied to the input image at the octave. Okay, if your image is captured with a weak camera with soft lenses, you might want to reduce the number. Okay, this is kind of hardware things then. So we see here, okay, yeah, but since maybe this is a parameter put before, because in older times the cameras are not really capable. Nowadays I don't think many people are using low level cameras, but again, just keep in mind this sigma is kind of some for hardware things I see here from this explanation. Yeah, we also learned now. That's good. I'm done for this video. Thanks for watching. See you in the next videos.